And finally, I want you to be aware of the non-deterministic nature of the input data and its effects on the whole analysis using simulation. So typically, what we have is a set of input variables representing the historical data regarding average time between customers or the income the gas station quotes per customers arriving in the past. So we have a set of observations, and we do not want to feed that information into the model directly. We want to do some analysis, and we want to get some kind of function that generalizes this kind of information. Okay, we can do that in several ways. One was to have an exponential or a uniform, but we can have other approaches, not by means of using a random variable. Once you have that, you have, for example, the information that customers' inter-arrival times follow an exponential distribution of an average of 2 minutes. You need to generate values that are according to this expression. So you need to generate random variables, okay? And that is something that most, if not all, discrete event simulation environments take care of very well, okay? But it is something that was not that well solved in the past. So sometimes you want to control these to do some advanced techniques for you to get better results, but this is beyond the scope of this playlist. Then what you have is the model, which is fed with input data, and you want to validate the results of the model. So what you want to do is to check what you got from your model with what happened in the real system. And again, you need to evaluate whether these numbers you get here are consistent with what will happen in the real world. And for that, you also need to work and to compare the the numbers, okay, in a fair way. And finally, when we look at the results, sometimes we want to check the configuration and see how the results are. And typically, as I said before, for every set of input data we put into the model, we get a different behavior. So we have a set of behaviors. So typically, we want to have some kind of characterization, some kind of description that allows us to decide whether this is something we like or not. So we have average values, we have confidence intervals, at least for us to get a first impression of how good our configuration is. And other times we don't want to analyze just one configuration. We will want to compare a set of those. We want to get the best out of several configurations. We want to get the 2, 3, 4 bests out of the total we're analyzing. So we need to do that in a systematic and rigorous manner. So we need to take care of that so that we do not draw wrong conclusions just because we see two different KPIs or two different average values. Again, this is not an explanation on how to do that. This is just a few remarks for you to be aware that the fact that we do not have a deterministic context but a non-deterministic one has an impact over the whole process, all the way from analyzing the historical data you have to the moment when you have to compare different configurations. I hope this set of videos allows us to get into the world of simulation and gives you an idea of what this technique is and when it should be used, and makes you aware of some relevant issues that you should take into account if you get involved in such a kind of projects. Again, I hope you enjoyed it and learned, and thank you very much.